Hi everyone, here we are on chapter 18, and chapter 18 is on solutions. And so there are going to be 3 sections in chapter 18 that I'm going to go over, but this particular video is just going to be on section 1. So this is just on section 18.1. Alright, so for this section you need to know the properties of the solution. So you need to know how you can get a solute to dissolve faster. So these are things that you are familiar with because you probably have done these things hundreds of times, such as stirring. So to get a solute to dissolve faster, for example, if you're trying to make, let's say, Kool-Aid or something, so to get the little sugar packet stuff to dissolve faster, you would stir it. Okay, and that is what we call agitation. So stirring or shaking would be something that you would do to get something to dissolve faster. Or another great example would be if you're making a protein shake. So those are things that many high school students will use, are protein shakes. So you have your powder, you add water, or you add milk or whatever, and you shake it up, right? So you use some type of agitation to get it to get your powder to dissolve faster. All right, another thing you can do is increase the temperature, right? If you increase the temperature, it will dissolve faster. So the example I like to use for this one is like hot chocolate. Like if you make hot chocolate using just the hot cocoa packets, and obviously if you use hot water, it's going to dissolve faster. But if you use cold water, if you've ever tried that before, then you might have experienced that it gets a little chunky and it's a lot more difficult to dissolve. But it will dissolve much faster if you use hot water. The last thing you can do to increase the rate of dissolving, you can increase the surface area. Okay, in other words, you can break it up into smaller pieces. For example, if you have a sugar cube and let's say you're trying to get that to dissolve, you can break it up into smaller pieces. Okay, increasing the surface area, therefore creating more smaller particles, therefore it will dissolve faster. The next thing you need to know is solubility, all right? And these are 3 terms that describe the solubility of a solution. We might describe the solution as being saturated, unsaturated, or supersaturated. So it is all related to the amount of solute that dissolves. And so let's first talk about saturated solutions. So saturated solutions already contain the maximum amount of solute at that particular temperature. So that means that it cannot hold any more solute. So any excess solute would just sit at the bottom of your cup or your beaker or your container. So you have probably seen that before, okay? So let's say sometimes people add sugar to their iced tea, and sometimes they stir it, and then it doesn't dissolve. Some of it just kind of sits at the bottom of the cup. All right, so that is telling us that the solution is saturated. It already contains the maximum amount of solute, all right, at that particular temperature. Now let's talk about unsaturated. So unsaturated contains less solute, okay, less solute than the saturated solution. So that means it has not reached that maximum point yet. So you can still dissolve more. Okay, you can still dissolve more solute at that particular temperature. Then the last term here is supersaturated. So supersaturated contains more solute than it should. Okay, so this is something that's like way beyond the saturation point, all right? A very good example is rock candy. Okay, rock candy is made out of mostly pure sugar. So what happens is they add so much sugar to the solution, okay, to the point where they have to heat it up in order for all of it to dissolve, okay? But as they allow the solution to cool down, it can no longer hold all of that sugar, okay, at a lower temperature. So what happens, all of the excess sugar will crystallize out of solution, and that's how we get rock candy, okay? There are a bunch of sugar crystals that have what we say crystallized out of solution. All right, so once again, supersaturated is where it contains like solute that is way beyond the saturation point, and in order to get it to dissolve, we had to heat it up, okay? But as we allow this solution to cool down, the excess will crystallize out of solution. All right, so that's supersaturated. Okay, so one of the questions on your worksheet is regarding, okay, so what if you have a solution and you're trying to test it to see if it is saturated, unsaturated, or supersaturated? What kind of test can you do to determine which one it is, okay? So what you can do is you can add in more solute, and if you stir it and it does not dissolve and it just sits at the bottom of the beaker, then it is saturated. If you added more solute and you stir it and it does dissolve, then it would be unsaturated, okay? Then what if you added more solute and it immediately crystallized out of solution? Then that would be a supersaturated solution, okay? Supersaturated solutions are very, very unstable, so they don't need very much in order to disrupt the solution to cause it to crystallize out. Okay, you also need to know the difference between the solubility of gases versus the solubility of solids. So let's talk about solids first, all right? So the solubility of solids will increase as the temperature increases, okay? So that means that solubility goes up because the temperature also goes up, right? And that makes sense, okay? For a solid, you heat something up, more of it is going to dissolve. So don't forget they go in the same direction, right? If they both go up or they both go down, then this is what we call a direct relationship. Okay, a direct relationship. Now, gases are the opposite, okay? So you can see here, solubility increases, so that goes up. Solubility increases when the temperature decreases. Okay, so solubility goes up, temperature goes down. So this is what we call an inverse relationship or an indirect relationship, okay? So your gases are more soluble in colder temperatures, whereas the solids are more soluble in warmer temperatures. So the example I like to give for gases is soda. Think of soda, okay? Soda contains, carbonation or CO2 gas, all right? So in order to get that gas to dissolve, we typically will stick our sodas into the refrigerator, right, where it's colder, because the gases are more soluble in colder temperatures. If you noticed, if you ever had hot soda or room temperature soda, it might taste flat, okay? It might taste flat, meaning there's no carbonation, okay? The gas is not dissolved into the soda. So that's why we stick it into the refrigerator to get that CO2 gas to dissolve into the soda so that it stays nice and carbonated. All right? So you do need to know the difference between the solubility of gases and the solubility of solids. And then here's just a little blurb about how solubility increases if you increase the pressure. Okay? So that's an example is that if you shake up soda or you shake up champagne or something, you've probably seen it on TV, they shake it up, they're increasing the pressure, right? And therefore, they will also increase the solubility of the gases, okay? And that's what will cause it to burst and spray all over the place, okay? All right, so now these are some graphs. The graph on the left here represents solubility of solids. The graph on the right represents the solubility of gases. So you can see how they are different. Okay, you can see how they're different. Solids, mostly their solubility increases as the temperature increases. Notice the gases are different, right? If you remember, this is what an inverse graph looks like. It curves down like that. Okay, so you should have an idea of what the graphs look like. And then now I'm going to show you the problems that you would typically see on a test that involve looking at a solubility chart. So these are solubility charts, or you can call them solubility graphs. Okay, so let's take a look here. let's take a look at question number 1. This one here, it's probably written correctly on your notes that you have, but this is not question 1. That one is question 2. All right, so question number 1. What is the solubility of KCl at 40 degrees Celsius in 100 grams of water? So what you need to do is take a look at what is being labeled on the X and on the Y. So on the X is temperature, and then on the Y it says solubility, okay, which is in the units of grams of solute per 100 grams of water. So what this is telling us it's going to tell us how much solute can dissolve in 100 grams of water, or it could be any other solvent. Okay, remember water is the universal solvent. So how many grams of solute can dissolve in 100 grams of solvent? And the solvent they're using for this graph happens to be water. So those are your units for solubility. Okay, so for the graph, we're looking at KCl, 40 degrees Celsius. Notice here it says in 100 grams of water. And that's exactly what this chart is based on, 100 grams of water. Okay, so we can take this number directly off of the graph. So let's plot our points, go 40 degrees Celsius here, and then let's go up to the KCl line. You have to be careful to make sure you're reading the lines carefully. And it's about right here. Okay, so then just estimate across the best you can what you think that would be. And so we would say that this is approximately, it's about in the middle, right? So I would say approximately 40 grams, okay, would dissolve in 100 grams of water. Now you would not divide these two numbers out. You would just leave your answer just like that, okay? So 40 grams in 100 grams of water. Okay, now question number 2 is slightly different. So in question number 2, what is the solubility of KBr at 60 degrees Celsius in 45 grams of water? Now remember, if we look over here on the graph is based on 100 grams of water, not 45, okay? So what we're going to do is we're going to find the value on the chart first, okay, based on 100 grams of water. Then we're going to set up a proportion to find out what that would be equivalent to in 45 grams of water, all right? So this is what I'm talking about. Okay, so KBr 60 degrees Celsius. So here we are, 60 degrees Celsius, and go find the KBr line, which is right there. Okay, so then estimate across what that looks like. So depending on how you want to estimate that, let's say that that's approximately 90. Okay, so let's say approximately 90 grams will dissolve in 100 grams of water. So that's based on the chart, the value that we got. But the question is asking how much will dissolve in 45, right, grams of water. So then we want to know what that would be, X over 45. Okay, so you see how I set up the proportion? Based on the graph, 90 grams dissolves in 100 grams of water at that temperature. We want to find out what that would be equivalent to in 45 grams of water. All right, so now just finish out your math. You'll cross multiply here, cross multiply there, solve for X. Okay, so go ahead and put that into your calculator and see what you get. So if you did this correctly, you should get approximately, let's see, 40.5 grams. Okay, so you can say it is approximately 40.5 grams, or you can write it as 40.5 grams in 45 grams of water. Either way, both ways would be correct. All right, so these are common questions that you would see regarding solubility and reading a solubility chart. So you definitely need to know how to do problems like this. Okay, so that is everything just for section 1. So we do have 2 more sections to cover, but we will do those on another day. Okay, so that is it for section 1. And now you can work on the chapter 18 worksheet and only work on section 1. So only work on the 18.1 portion. All right, see you later. Bye.